So far in our course, we've learned how to write some simple Python, to control some output devices, and to detect events from input devices. In this session, we're going to throw that all together to make a simple physical reaction game. Let's get started, much as we have before, by opening up Python from the programming menu. And again, we're going to skip the shell and go straight for a program. Let's save our program first of all. Let's call it reaction game. And in our program, we're going to need to add a few imports. So first of all, we're going to import from GPIO0 not only an LED, but also a button. We're also going to want from the time library, time to give us the current time, and sleep to allow us to pause. And finally, we're going to add a new function in from the random library called randint. And this will allow our program to generate a random integer or whole number between a specified range. So, let's just test that our components work first of all, which is a really important step in any program that involves physical components. Let's take our LED and set it up on pin 17. Let's take our button and set it up on pin 4. And then to test that these components work, we're going to write 3 lines. The first line to turn the LED on, the second line to wait for the button press, and the third line to turn the LED off. When we run our program, we'll be able to test that our 2 physical components are working correctly before we continue with the rest of the program. So let's run that. The LED comes on, we press the button, and the LED turns off. Great. If this doesn't work, go back, debug your hardware, check all the connections match the diagrams in the course before continuing. Believe it or not, we've actually got most of our program written now. This program is very similar to the one we wrote in the first session where we had a simple reaction game, except instead of print messages, we've got LEDs coming on and off, and instead of inputs, we've got button presses. Let's build on this and turn it into a true physical reaction game. First, let's add a while loop before our final 3 lines, and then indent these 3 lines so they're inside the loop. Now in our first program, we made it sleep for 5 seconds. However, what we're going to do this time is we're going to generate a random number using our randint function. Inside that we give it a range, so 1 to 10. We close the parentheses both for the randint function and the sleep function, and that line will generate a random sleep between 1 second and 10 seconds. Before the LED comes on, we wait for the button press and we turn the LED off. Let's just try that now. We wait for the LED to come on, it comes on, press the button, and the LED turns off. After our LED on line, let's capture the current time. So we're going to say start equals time, and that will store the current time in the variable called start. Then, just after we've turned the LED off, let's capture the end time. So we're going to say get the time and store it as the variable end. And finally, we're going to print a message out. And all we're going to do in this case is just do a quick calculation, end minus start, and then print out the number of seconds. And so now, when I run my program, so the LED comes on, I press the button, it turns off, and I get my reaction time of 8 seconds. Not so good. Let's run that again and see what we can do now. 2 seconds, getting faster, much better. So there we have it, a simple reaction game using LEDs and buttons written using about 12 lines of code. Using this kind of thing, we could then build it into a physical case, we could turn it into a 2-player game. There's a huge number of ways in which we can adapt this and get our students really engaged. That's the power of digital making.